Now sometimes it makes sense to use long multiplication. Let's look at this problem. We've got 37 multiplied by 768. Can we do any fancy stuff by just thinking about that place value like last time? Well, there's no zeros, so there's no shortcuts there. So let's forget that method. If we actually split the problem into lots of different parts by place value, which is really the same thing, we would start off with 30 multiplied by 700, and we'd have 5 more problems. Now, we can't get out of doing that many calculations, but we can do it in a way that we don't lose track of them. We could use the area method, where we would actually split 768 into 700 plus 60 plus 8, and 37 into 30 and 7. And we'd work out each of the areas and add those 6 different areas together. So once again, 6 different problems. That's a great way to do it. But we're going to actually use long multiplication here, because this method is probably the quickest way of doing it. You're still doing the calculations, but you actually start, when you use long multiplication, to become quicker at solving them, because it's very similar to the area method, or splitting by place value, but it's all in one little place. So let's have a look. If we've got 768 multiplied by 37, we start with the units. We multiply 7 by 8 units, because we start on the right hand side of that number as well. And that's 56. So we put 6 down in the units place, and 50 of the units carry over to the tens. Now we actually multiply 7 by the tens, and we get 42. 7 sixes are 42, and 5 makes 47. So 47 tens, we put the 7 down, and 40 of the tens carry over to the hundreds. Now we're ready to multiply our 7 by the hundreds. 7 multiplied by 7 is 49, and 4 is 53 hundreds. We could actually write that as 3 hundreds and 5 thousands. Oh, a light bulb moment. Now what we actually just did is the same as what we would have done if we used the area method of multiplication. We multiplied 7 by 8 units, which is that section, 7 by 6 tens, or 60, which is that little rectangle, and then we multiplied 7 by 700. So in fact we've done the same as what we would do using the area method of multiplication. We've just written it in a long multiplication format. Now let's push on and do the next part. Okay, so we're going to multiply 3 in the tens place, so we have to put a 0 down because 3 is actually 3 tens, so we need that 0 there. So 3 eighths are 24. We can put our 4 in the tens place, but we're going to rename those 20 and actually put a 2 above our 6, so we remember that it's there. Now we can multiply 3 by 6, which is 18, and add on that 2, which gives us 20. So we're going to need to put a 0 down and carry over that 2 to the hundreds place. Now we can work out the last part. 3 sevens are 21, add on that 2, and we get 23. So we put our 3 there and our 2, and we're ready now to add the digits up. Let's have a look. We've got a Oh, yes, of course. Let's remember the area model. We had already worked out the first 3 parts. Now what we've done is we've worked out 30, which is 3 in the tens place, multiplied by 8, which is there, and then we multiplied 30 by 60, and then we multiplied 30 by 700. Now we didn't say 30 by 730 times 60 because we used long multiplication, but it was very important that we had our digits in the right columns. Now we can add them up. We've got 6 in the units place, 11 in the tens place, so we pop a 1 there and rename 10 to one of the hundreds. 1 and 3 is 4 in the hundreds place, 5 and 3 is 8 in the thousands place, and 2 is in the 10,000s place. So we've finished our problem, and what we've actually done is we've solved the same thing as what we do with the area method. We've just done it using long multiplication. So you see we get the same answer. So what does it all mean? Well, it really just means that whichever method we choose, we're solving the same problem, We just might go a different way about it, and sometimes you might feel one way is easier to do or makes more sense to you